Hello everyone, and welcome to a new Plotly Dash video focused on the amazing component Dash AG Grid and incorporating some AI functionality, where we are going to be building out this table, which is a dynamic table which allows us to filter, do a bunch of other great things. So greater than, we could just say anything greater than 5,000, and it will filter all of our data. But yeah, great filtering capability within this. The data is paginated, as you can see here, and what I provided is an AI generated summary. So basically what you could do is you can get an API key from Gemini, you can put that API key in the configuration and actions, and you can generate an AI summary based off of the data set that we are working within. And it will pass that data set through the AI, and the AI is going to generate a summary on the data that we are working within, giving us better insight into the data set and key metrics and reasoning and basic understanding of what this data set is trying to tell us. So as the data set evolves, you can get a generative AI response to what the strengths of the data are, the weaknesses, the way that it is growing, and you could better understand the direction of your data and the story that it's trying to tell. So in this example, it gives sales performance analysis and strategy insights in a report. This is going to give us an executive summary, performance analytics, customer satisfaction insights, regional strategy recommendations for what we could do per region to help increase the numbers, and then product portfolio organization suggestions to change up our portfolio, marketing investment recommendations, risk factors and areas of concern, and specific actionable next steps. So this is a lot that the AI was able to generate and to give us insight into our data set. So to get started, you're going to need to get a API key with Gemini. Outside of that, we're going to need to pip install Google Generative AI. So we're going to start off with a fresh package, and I'm going to showcase how this was built. So going into the code, we will basically create a new app.py file. And what I'm going to instruct you to do is to pip install, and the first one is going to be the Google Generative AI, and then the next one is going to be, we're going to pip install Dash AG Grid and Pandas. So once both of those have been installed, then we could start working within the project. So just to kind of keep this fast-paced and make it just kind of cover the key factors of the code, I'm going to import sections, and we'll talk about each section. So the first thing that we're going to need is going to be the imports. We're importing Dash. I am going to change this just a little bit. I'm going to also bring in Dash again, and I think we might be able to get rid of that one, but we will see. So the next thing I'm going to do is I'm going to define the app. This is going to initialize the Dash application, where I'm just going to say that this is going to be a dash.name, and I don't know if we need the name anymore, but we will just keep it because Dash is backwards compatible, and that was the way that you were able to initialize a Dash application in the past. So this one we're going to name the title. We will name this AI Dash AG Grid. Okay, so with that, the first thing that you should do when building out a project like this is define the functions that are going to be used within the actual application. We have a basic understanding of whenever we want to create this, we're going to want to create a function that generates the data for us. So I'm going to copy and paste this quick function that I already created and give you some insight in how it works. So I'm using a lot of NumPy, and I'm using NumPy random to kind of generate the data set in itself. The way that this works is I'm providing a date range. The date range is based on a period of 200 different values in the data set. So it's basically looking for a range that starts at this date and it goes all the way up to today. But it has to basically create 200 different data points within that data set. So that's going to be the dates. Right above here, this is a seed that you can provide to have the data show up the same way depending on the seed number that you are shown. So if you are using a seed of 42, every time that you use that seed, you're going to get the same data set in regards of the response of each individual variable as you generate it. So Outside of that, I define a dictionary. Within that dictionary, I'm passing through the dates that I generated right here. Then I start generating more data based off of the region. The region's going to be using a choice between north, south, east, and west. Just the different regions. We could scale that out to countries if we wanted to, but for this example, that's perfect. Product is also using a random choice of what type of product is this referring to, where I'm giving it a few options, and then I'm saying that the size is going to be 200 points of data. Below that, I'm going to be using MP random normal, which is going to provide a sales of what that number will entail. We can also make this a little bit cleaner if we wanted by adding underscores, and this counts the same as just having 5,000. It's just an easier way to look at it. But with that, it's generating 200, and the minimum value has to be $100, and it's going to be arranged typically between 1,500 and 5,000. So moving down a little bit further, for the units, it's going to be another random interval where it's going to say 550 and between that range, and it will generate 200. Customer type, it is going to give us a business to business or business to customer, and it's going to basically give us a size of 200, and it's going to give us this way of just saying that 60% is going to be B2B, 40% is going to be B2C. So that's what that is saying. Satisfaction score, that is a NP random uniform where it's going to be a 3 or a 5. It's going to be in between that range, and it's going to generate 200. And then for the market spend, it's going to be still using the NP random uniform between 100 and 1,000, and it's going to generate 200. So within that, now that we have that dictionary created, we're going to pass that through a data frame. After that, we are going to add seasonal variations. This is just a way for us to add some variety to the sales, and that's going to just make our data look a little bit better in this test data set. So this is going to calculate derivative metrics like revenue. It's going to be based on the sales multiplied by the units. Profit margin is going to be a base of 15%, and it's going to pick between this random selection. The profit is going to be revenue multiplied by profit margin, which is this above. So it's going to multiply both of these. And then ROI is going to be based on a divide of the profit divided by the marketing spend, multiplied by 100. So now that we have our data all set up, we can start moving down to basically defining it and setting up our columns for our -AG grid. So we have an idea of what the data set is going to consist of. We are going to basically bring the data set in to the actual application by hitting on the function. So as you can see, it added a use. So now this is actually being ran, and it's being given to this df variable. So we are going to convert the date string to format for a JSON response, which is just going to make it easy for the -AG grid to work with. We are going to enhance the AG grid by providing custom column names. And this is how you can do that. You define a column definitions, which is going to be a field, and it will be a header name and then a filter. So you can give these attributes to the column definitions, which will allow a cleaner way to view the -AG grid as it renders. Moving over to the front end of the application, we need to define the layout. So what I just pasted is going to be the app.layout. This is going to give us a header, which is going to just give us context for what this application is. Then we are going to provide a section for them to input the API key and an export button for the data set itself. So this is where I am throwing in the configuration options, where I have a DCC input, I have a button to generate an AI summary, and then I have another button that is going to be the export. I am giving a DCC download for the CSV for if that download button is clicked, and then I'm giving a loading overlay. Outside of all that, I have API key status to give an understanding of if anything went wrong. But what you need to pay attention to is going to be the IDs. The styling attributes are unique for each individual section to just make it look a little nicer. But that is basically it. Then we have a summary display, which is going to pass through the summary content on the click of the AI summary button. It will basically automatically generate a DCC markdown. So the DCC markdown is a great tool within the Dash framework, which allows you to generate a markdown file to view directly within the Dash application, which makes everything look so much cleaner and is nice. So below that, we have a filtered data, which is going to be a display of none, and this is a hidden div to store the filtering data. So with that, the layout is relatively simple. We are at about 210 lines of code. Now we can kind of start working with the callbacks, and this is where the magic starts happening within the Dash framework. We're going to bring in this callback, which is the store filtered data, where this is going to take an input of the data grid, which is the virtual row data within that, and the output is going to be the filtered data. So this is basically updating this hidden div with children of a base understanding of the virtual row data within the data grid. And the data grid is going to be the Dash AG grid right here. So this is where we are passing through the data frame and we are turning it to a dictionary for the row data. We have that ID, and then below that we are passing through that column definitions, which we defined right here, which allows us to define the headers and all that other useful information. So we also have default column definitions, which are just automatically applied to it as well. We want to have filtering support, so we gave that true. Resizable, we gave that true, just looks nice. Floating filters, we gave that true. And then we also have Dash grid options. If we would like it to be paginated, we could pass that through that dictionary in that prop. Pagination size, and then just kind of giving some more specification for the row selection and DOM layout. So with that, we need another callback, which is going to be used for the CSV export. So the way that you can configure a button to basically retrieve the Dash AG grid data and to export as a CSV is relatively simple. It's only about maybe 10 lines of code, but what we are doing here is we are providing an export button where we are tracking the in clicks. So whenever anybody clicks on that button, then it's going to trigger this callback, okay? This callback is going to look for the state of a current component. So it's going to look for the filtered data. This is going to be the store of the data. So it's going to look for the data that is in and stored within this div. Then it's going to basically download via this output. This output is going to be related to this DCC download with an ID of download data frame CSV. So that's the ID. So within this function, it's basically tracking that click of the input. The state is going to be this right here, which is going to be the filtered data. So once this is triggered, then it's going to load in the filtered data. It's going to turn that data into a data frame. And then if date stream is not configured correctly in the column, then it's just going to filter and rename that so that it is now date string for the column name within the dates. Then we are using dcc.send data frame, and we are passing through the filtered data frame, which is this data frame object, and we are turning that to CSV. And we need to provide a name, which is going to be data export. We are giving a date time of now, and we are stripping it to basically transform that date time now object into a readable date time object. And we are just adding the .csv at the very end. So we are almost done here. I have one more callback, and then we can actually work to run this code. But I'm going to copy this and bring it in, and we can kind of talk over it. So this is going to be to generate the enhanced summary through the AI. So this is the actual AI that is going to be used within the callback So what I just did there is I imported no output. And the reason why I did that is whenever this callback is ran, if there is no end click, we don't want it to do anything. So basically, if the end click, which is the input of the generate summary button, is never hit, then don't do anything. If there's not an API key associated with the state of API key input, which is in our layout, and there's no value in that, then I don't want you to do anything. But I want it to give a message. So for example, it's not going to generate the output for the summary content, but for this API key summary status, so just did it work or did it not, that status message, it will return a message indicating that the API key didn't work or to please enter in an API key. So then we are going to use try and accept to kind of make this clean and to provide a catch-all if anything goes wrong. The catch-all is going to basically return a markdown message if something went wrong, and then the actual return of a successful response is going to be this try statement. First thing we need to do is we need to configure Gemini. So we are calling on the import Gemini configure, and we are passing through the API key. The API key is coming from the input API key input. So it's going to look for this input and it's going to pass it through this. This is provided through the layout in that input section for the API key. Then we need to define a model. So we are giving a model variable and we are using generative model, and we are passing through the actual model that we would like to use in this example. Then we are going to start parsing the filter data. So we are calling on this new variable filter data, and we are loading in the filter data JSON that was from the initial callback that we already outlined. Then we are going to turn that into a data frame where we are just going to pass that JSON data into a data frame. And then we are going to define a way to handle the date conversion. So this is going to allow us to pass the date in between the actual JSON into a readable object that the AI can use. So we're going to say if the column is date underscore string, then we want it to do this. And if it is date, then we want it to do this. So with that, we're going to calculate additional metrics, which are going to be used in the data summary. But this is just looking at the date, the region, the product, the satisfaction score, and it's giving the mean. And we're just kind of running a little bit of math on that by grouping it through the data frame that we have defined, and then getting the sum, or we are getting the mean, and we are multiplying it, or just kind of doing that pre-logic. So for the enhanced data summary for Gemini, it's best to be as specific as possible. So what I did is I defined this whole analysis to pass through automatically to the Gemini AI, so it has as much context as needed to start using the power of AI to give that summary and response. So I basically prompted to analyze this comprehensive sales data from the data that we are working within. I give a data science overview of the total number of records within the data, the date range that the data set covers, the unique regions, the product categories. I give some ideas of key performance metrics that could be useful in the AI to have better context of what we are working on, where I'm just passing through revenue, profit, profit margin, unit sales, revenue growth. For customer insights, I am giving an average satisfaction score, and then I'm also passing through customer type and revenue split. Regional performance, I'm passing through another data frame, and then for product performance, I'm passing through the product data frame, where I am basically getting the sum, the mean, and kind of just turning that into a dictionary for it to work with. So marketing effectiveness, I'm going through the market section within the data frame, and I'm getting the sum, I'm doing the ROI, and then I'm grouping it and just giving it as much context as possible. Then I am asking it for what I want in return. Every time that response and this callback is hit, this is what I want the AI to do. So I'm saying, please provide an executive summary. Please provide an executive summary. Performance, analytics, and specific numbers and percentages, customer satisfaction insights, regional strategy recommendations, product portfolio, risk factors, 3 to 5 specific actionable next steps to expand or work with, increase the flow of the data and what the data is trying to tell us. And then basically I give it some formatting guidelines to basically start prompting it to design the response in a markdown format. So this is what this last section is doing. So with that, I'm giving the response generative to a model.generate content where I'm passing through that variable data summary. And then I am going to be returning this DCC markdown, and that is going to take in place the summary content. So that's what's actually shown on the Dash application. Lastly, we cannot forget we need to actually run the application. So to run this in a development setting, we just provide an if_name equals main app.run, and then we provide a port, and then we can run it, and what we have is our application. So with that, I know that this was a lot to cover, but there was a lot of insight into Dash AG Grid, how to kind of configure a full Dash application, along with integrating AI directly within our code. And with this video, I hope that this gives you the knowledge and the inspiration to go into any direction you wish and to build and innovate something amazing. So with that, thank you for watching. Like, subscribe, check out our other videos as we have a lot covering AI or Dash AG Grid or Dash Enterprise, a whole playlist of different things that you can watch to better understand how this framework works and the powers that it is able to unleash. And with that, thank you for watching, and I'll see you guys in the next one.